Swayam Prabha. Digital India. Educated India.
Hello and welcome back everyone. Today we are going to take a quick recap of all the modules we have studied so far in the basics of building construction. So what we are going to do is, we are going to start off with the absolute bottom of the house. We'll see the foundation first, then move on to the masonry walls. Then we'll revise about the flooring. Now foundation can be broadly classified under two heads, shallow and deep foundation. What's the basic difference? Foundation is said to be shallow if its depth is equal to or less than its width. In case of deep foundation, the depth is equal to or greater than its width. Now, if we subcategorize shallow foundation, we will see predominantly it can be of four types. The first is called spread footing. The second is called combined footing. Third category is strap footing. And finally, we have mat or raft foundation. Now, spread footing can either be strip footing or pad footing. Now, strip footing is when we are having the footing under a particular wall. Now, pad footing is when we are having an isolated footing under a column. Now, strip footing can further be with and without masonry offsets. So, masonry offsets is basically the steps of bricks that we are creating under the footing. Now, why is this done? When we have more load and the size of the concrete base is not enough for us to transfer the load at the right angle, we actually have to step it up by adding some masonry offsets. So, that is strip footing with masonry offsets. Pad footing can either be a simple pad footing. We can have a stepped pad footing. Again, here we are providing some offsets for the load transfer at a certain angle. For RCC columns, you actually have an integrated RCC pad footing. Then comes grillage foundation. Now, this is a special type of pad footing for steel stanchions, and they can either be made with steel grillage, or we can also have a timber grillage foundation for a timber post, to support a timber post. Now, the characteristic of this particular type of foundation is that it has tiers. So, you have a top tier, and at 90 degrees you have a bottom tier, and then on top of that the structural member comes and rests. Now, if we are dealing with a situation where we are at the property boundary line, or two columns are very close to each other that need to be supported, it's possible that the size of the footing is such that they are overlapping each other. So, in that case, we can go for a combined footing. Now, combined footing is supporting two columns at the same time. It can either be rectangular in shape if the load in both the columns is same. It can be trapezoidal in shape if the load in one is more than the other. And it can be continuous footing if you are dealing with more than two columns. So, if you have three or more columns continuously back to back, in that case, it can be a continuous footing. Now, strap footing is another type of shallow foundation where you are connecting two adjacent structural members. But in this case, the strap is only holding hands. It's only transferring load from one to the other. It itself does not have any load bearing capacities. The mat or raft foundation is a type of shallow foundation in which your entire base of the building is covered by a mat of foundation. So, we can use even basement walls or ribs or pedestals to kind of create certain portions with greater strength than the other. But what we are doing is, at least the area of the entire house, if not more, is covered by the entire foundation. Now, we do this when the bearing capacity of the soil is very low and the size of the footings are coming pretty high, or it may so happen that they are very closely spaced together. So, it's more economical for us to go for a foundation for the entire thing. In general days, we can see that in the staircase or the lift lobby portion of a building, maybe there is isolated pad footing for most of the columns, but for the lift portion, because the columns are coming pretty close to each other, we can go for the raft or mat. Now, let's move on to deep foundation. Now, here the depth is larger than the width. Now, generally they can be of three types. It could be pile foundation, pier foundation, or Cassian or well foundation. Now, shallow foundations are different from deep foundation on another aspect, not just the depth. The second thing is, shallow foundation is actually open type of foundation, because there you have to actually dig a trench to create that type of foundation. But in this case, you don't need to do open excavation. Deep foundation is also different in that aspect. So, let's talk a little bit more about the pile foundation. So, pile foundation can be made up of concrete piles, timber piles, steel piles or composite piles. Now, other than this classification of pile on the basis of material, piles can also be classified on the basis of operation or function. For example, they could be end bearing piles, friction piles, based on how they are transferring load to the ground. They could also be called as, dolphin piles, fender piles, sheet piles, depending upon the shape, the place that they are being applied. But here we are only revising the material based classification of piles. So concrete piles can be precast or cast in situ, that is made on the site. Now cast in situ piles can either be driven piles or bored piles. Here we are talking about the action with which we are actually inserting the pile into the ground, whether you're driving it or you're boring a hole into the ground and creating the pile. Now driven piles can be cased or uncased. So cased means it is covered by a certain envelope or shell, and uncased is it is just the concrete which is in contact with the ground. Bored piles can be pressure piles. These are created with the help of air pressure. We can have underreamed piles, also applicable in black cotton soil because they have a little bulb which helps us secure the foundation well. So underream tools are used to create underream pile. We can also have bored compaction pile, which is a combination of bored and driven piles. Steel piles can be further classified on the basis of shape into edge piles, pipe piles or sheet piles. And composite piles essentially means it's made up of two materials. So it could be concrete and timber, concrete and steel. But in the end, altogether, it acts as a single entity. Concrete cast in situ piles can be cased or uncased, as already mentioned. Just to recap the names quickly, Raymond pile. Raymond can be a Raymond standard concrete pile or a step taper. This is a very simple pile. It is slightly tapered in shape. The MacArthur cased pile is more straight in shape. The Union metal monotube pile, swage pile and western button bottom pile are the other types of cased piles. Cast in situ cased piles. Now, swage pile and western button bottom piles actually have a bulb in the end of a specific shape. The swage pile has a plug shape. The western button pile actually has a mushroom kind of a button shaped entity at the end or bulb at the end of the pile. The uncased pile can be simplex, Frankie, Vibro or MacArthur pedestal piles. So these are the subtypes of cased and uncased pile. Moving on to the second module, which is on masonry. Now, depending upon the type of building unit we are using, masonry can be classified into brick masonry, obviously made up of bricks, stone masonry, composite masonry, hollow concrete block masonry, reinforced brick masonry and glass block masonry. Now, based on the design, we can use traditional bricks or we can use modular bricks. Modular bricks have very specific size. Based on quality, we can classify bricks into first class, second class, third class, fourth class. Here, first class is the best quality of bricks. So, based on shape, based on brick portions, we can further classify bricks. Here we can see this is what a single bull nose looks like, followed by a double bull nose, cow nose, curved bricks, coping brick, bird mouth brick, cant brick, double cant brick. So this shape will be repeated twice. We can have a squint in this shape. We can have a plain stretcher splay splayed along the stretcher side. We can have a plinth header splayed along the header side, and we can have a dog leg brick. So this is classification of bricks on the basis of shape. We can also classify them on the basis of portions. This is a full brick, a queen closer half. We have just divided it along the stretcher. Queen closer quarter, we've taken just 1/4 of the brick. King closer connecting the central points on both sides. Beveled closer, mitred closer at an angle of 45 to 60 degrees. Half bat, 3/4 bat and beveled bat. So all these shapes and portions have application in different aspects. Especially the brick portions help us to stagger the courses, as in when we are creating the brick courses, the lines, vertical joints cannot coincide. This will reduce the structural stability of our brick wall. So to avoid that, we often have to stagger these joints. To be able to do that, we use brick portions in each course to stagger that joint. We can classify brick bonding into different types. Stretcher bond, we're not going to get into the details of each of them. We're just taking a look at the names, just to recap, and we have a lot of modules to go through. So stretcher bond, header bond, English bond, Flemish bond, facing bond, English cross bond, rat trap bond, brick on edge bond, Dutch bond, raking bond, zigzag bond and garden wall bond. Different applications will require different way of arrangement. So these different bonds can be used depending upon where we are applying them. One which is not listed here is that there are many decorative bonds also available like herringbone pattern, etc. If you want to further study in detail, please refer to module 2 for the same. If we are not using bricks and going for stone masonry, we can have rubble masonry. The blocks of the stone here are quite undressed and comparatively rough. In ashlar masonry, these blocks are accurately dressed. They are having proper joints together, and we're using specific sizes of stone to actually create this masonry. So we can have rubble masonry, we can have ashlar masonry. In case of composite, we are actually using different building units together. This may be adopted for the improvement in the appearance of the wall, or if local materials are available and we want to optimize economically. So we can have a combination of stone composite masonry, we can also have a brick stone composite masonry. Concrete, cement concrete masonry can also be done. There are different shapes of blocks which are available that we can use depending upon the application. We had also studied in this module a little bit about arches. Now, arches can be classified on the basis of shape. The first classification of arches on the basis of shape means we can call it a flat arch, segmental arch, semicircular arch, horseshoe arch, pointed arch or Gothic arch, Venetian arch, Florentine arch, relieving arch, steel arch or semi-elliptical arch. We can also classify arches on the basis of number of centers, that is 1-centered arch, 2-centered arch, 3-centered arch and 4-centered arches. This will refer to the number of arches that you have to create to give it the entire shape. So the number of centers of each of these curves will define the number of centers in the arches. Classification can also be done on the materials and the type of workmanship expected. So stone arches could be rubble and ashlar. We can have brick arches. So we have rough arch, axed arch or rough cut arch, gorged arch and purpose made brick arch. So in this particular type, we actually have specific voicers created in a shape and put together to form the arch of a desired shape. We can also have concrete arches in which we can use concrete block units, or we can also have a monolithic arch which is created in totality. The next module was on flooring and its types. Floor is any level surface that is capable of bearing the weight of the building, occupants, furniture, equipment and internal partition of the structure. If it is in direct contact with the ground, that level is known as the ground level floor. If you are having a basement, that will be called the basement floor, and all the upper story floors are going to be known as upper floors. Now the common floor material or the finishing material that can be used is mud and muram. This is for more economical constructions, affordable constructions. We can use bricks as well, mostly used in outdoor portions or semi-covered portions. Flagstones, concrete, terrazzo flooring can be done, mosaic flooring can be done. We can definitely use tiles, very popular these days. Marble for more premium constructions. We can have granulithic finish, wood or timber if wood is more temporary, locally available, and also if wood is affordable for us because of its availability. Definitely not in a place where a lot of moisture is expected. We can use asphalt, rubber, linoleum, cork and even glass for our flooring. Glass of course can be used in places where we want light from the upper floors to infiltrate the lower spaces. Plastic or PVC and laminate may also be used as floor covering. For upper floors, there are different types of floors that we can go for construction purposes. We can use steel, joists and stone or precast concrete floors. It's also possible for us to use jack arch floors. Jack arch floors can further be subdivided based on the material that is used. We can use brick jack arch floors and concrete jack arch floors. Reinforced cement concrete floors are also possible, in which case we can have several subtypes. It could be a simple slab, reinforced RCC slab flooring, reinforced brick flooring, beam slab flooring, Flat slab flooring, this specially allows us a lot of space underneath the slab because we're reducing the depth of the beam arrangement, increasing the floor to floor height. We can also use ribbed or hollow tiled flooring in case we want to reduce the weight of our slab by doing away with the excess of concrete in the lower half of the slab, because when we look at the slab cross sectionally, the upper part takes the compression, the lower part takes the tension, and in that case we have the steel bars taking that tensile stress. As a result, we do not really need concrete in that portion. We can actually replace that with the help of hollow tiles, and that, number one, provides insulation properties, acoustical properties. It also helps us reduce the self weight of the slab and the overall reinforcement required in the total slab. We can also have filler joist floors, precast concrete floors, and timber floors as well. In case of timber floors, we can have single joist timber flooring, double joist timber flooring, or we can have framed or triple joist timber flooring. Now, the name basically is coming from the number of members that we are using to create this type of flooring. In case of reinforced concrete floors, we can have as already mentioned, symbol slab flooring, reinforced brick, beam slab flooring, flat slab flooring, and ribbed flooring. Now, moving on to the next module, which is on doors and windows. A door is a solid openable barrier which is fixed to a frame in an opening, and it's supported on the walls to hinge, pivot, or slide to open. Primary use is to go from one room to the other or go from inside to outside. Now, windows are an opening where we can have visual access but cannot actually go through it. This is basically for daylight and natural ventilation of the indoor spaces. Based on the arrangements of different components in a door, we can call a door battened and ledged, battened, ledged and braced, battened, ledged and framed, or a combination of all the four, that is battened, ledged, braced and framed doors. So, this classification is happening on the basis of different components in the door. Method of construction can also be used to classify doors. So, we can have framed and panel doors, glazed or sash doors, flush doors, louvered doors and wire gauged doors. On the basis of operation, that is how the door actually operates, we can have revolving doors, sliding doors, swinging doors, collapsible steel doors and rolling steel shutter doors. For metal doors, we can further classify them into mild steel sheet doors, corrugated steel sheet doors, hollow metal doors and metal covered plywood doors. So, that means we can classify our doors on the basis of, number one, arrangement of the different components in the door, 2, the method of construction, 3, the basis of operation, and 4, we can further subclassify metal doors. With respect to windows, again we have several types. In the way they are shaped, in the way they are placed, we can call them by different names. Fixed windows, pivoted windows, double hung windows, sliding window, casement windows, sash windows, louvered windows, metal windows, we have bay windows, clear story windows, corner windows, dormer windows and gable windows, which are possible in pitched roof houses, lantern windows, skylights, ventilators and a combination of window and ventilators. The next module was on roofs. A roof is a structural element or member to support the roof coverings. These structural members can be trusses, portals or beams, and the roof covering can be AC sheet, GI sheet, wood shingles, tiles, slates or slab. If we want to further classify pitched roofs, it can be a single roof, a double roof or a triple member roof. The name is different based on the number of wooden components that we are using to create this roof. In case of single roof, we are only having the common rafters that is being supported at two ends, one at the wall end and the other at the post end, let's say. So, the single roofs, if we are having it more than 2.5 meter in width, the common rafters will become uneconomical. In that case, we would have to add an intermediate member called a purlin to support this particular member in the middle. This will allow us to divide the rafters into two parts, 2.5 and 2.5 or less than that. As a result, the size of the rafters can be reduced and the weight of the roof reduces. So, because we are adding two members, rafter and purlin. It is known as a double or a purlin roof. Sometimes when we have to go for additional members, that is such that we do not have a wall inside the room to support our purlin, then what do we support the purlin on? In that case, we can add trusses. Now, trusses actually allow us to support these purlins in the intermediate position without taking help of any structural member or wall in the space underneath. That allows us to have columnless or free spaces underneath the trusses. That becomes a triple membered roof. Now, trusses can be further classified on the basis of shape in which the members are put together. We can have a king post truss which has a single vertical member in the center. We can have a queen post truss where there are two vertical members spaced out and connected with a horizontal member. We can have a combination of king and queen post. We can have mansard roof and truncated roof truss also, which is a combination of those two, but there is a shape change by having a different pitch and different parts of the roof. We can have a Belfast or lattice roof truss, a composite roof truss and steel sloping roof truss as well. We can further classify steel sloping roof truss into various shapes. Now, lean-to roof is a very common simple type of roof where you are leaning in only one direction. The gable roof is such that the slope is in two directions. The hip roof is sloping in four different directions. The gambrel roof is again sloping in two directions, but there is a change in slope or pitch along the slope. Now, mansard roof is again sloping in four directions, but there is a break or change in the pitch. Now, deck roof again sloping in four directions, but there is a flat surface created on top. So, this is common types of shapes of pitched roof. As we were talking about steel roof trusses, it's possible for us to further subdivide them into various categories depending upon the shape in which they are created and also the span that they are applicable for. We can select the type of steel roof roof truss which is applicable to us by determining what is the span that we have to cater to. So, we can have king post, scissor truss, raise cord, hoe truss, simple fink, fan fink, and we can have modification of knot light trusses as well. As we go up to compound fink, compound hoe trusses, we are actually increasing the span. We are able to cater to a much greater span wall to wall to be able to deal with this. There are many types of roof coverings that can be used on top of our roof structure. We can have thatch covering. This is far more economical, not very durable and also fire hazard. Wood shingles, tiles. There are many shapes of tiles which are available in the market that can be used. We have asbestos cement sheets, galvanized iron corrugated sheets, Eternit slates and lightweight roofing materials as well. Even that has several subcategories. The next module is on PCC and RCC. First, let's take a look at PCC. Now, cement concrete is essentially obtained by mixing cement, sand, aggregates and water in a proper proportion, and then it is cured to form a hard mass. Now, we can create it by using different types of cement. Cement can be Portland cement, which is the most popular type. Now, Portland cement can be further subcategorized as ordinary Portland cement, rapid hardening Portland cement, extra rapid hardening cement, low heat Portland cement, Portland blast furnace slag cement, Portland pozzolana cement, sulfate resisting cement, and white and colored Portland cement where a coloring agent is mixed with the cement. There are special types of cements available which include masonry cement, trife cement, expansive cement and oil well cements. Now, these have different characteristic properties and they can be used in different places. There are other types of cements as well which include high alumina cement, super sulfated cement and natural cements. The basic composition of Portland cement is that it includes lime, silica, alumina, iron oxide, magnesia, sulfur trioxide, soda or potash. Mostly lime and silica form its constituent parts. These are the subtypes of Portland cement that we were just discussing, and special cement and other cement subcategories. There are many quality tests that we can perform on our cement to ensure it's the right kind. We check for first the chemical composition, followed by the fineness, the soundness, the setting time, the tensile strength and compressive strength, and the heat of hydration. With respect to the aggregates, we can have fine aggregates and coarse aggregates. Coarse aggregates are the ones which have a size more than 4.75 mm. We can check the quality of our aggregates and suitability by checking its strength, size, particle shape, impermeability, chemical inertness, surface texture, grading, cleanliness, cost, physical and chemical stability, and coefficient of thermal expansion. When we are testing for the concrete, which is achieved by mixing our cement, fine and coarse aggregates and water at the right ratio, again reminding you that there is something called water cement ratio, which is the proportion at which we are mixing the water and cement. It has to be kept within a certain permissible limit. If it exceeds beyond that, it actually reduces the strength of the cement concrete. Now, concrete has several properties. We check for its strength, durability, workability and economy. For checking the strength, we do the cube test. For the durability, we do the water absorption test, water permeability test and rapid chlorine penetration test. Workability is probably one of the most important characteristics which tells us how easily we can handle it on site. So, for this we do slump test, compacting factor test, VB test and Vibro workability test. With respect to economy, we must ensure that strength, durability and workability of the concrete is ensured with minimum cost. When we are preparing and laying the concrete, it can be divided into 6 main stages: batching of materials, mixing of materials, transportation of the concrete from where it has been batched and mixed to where it is to be placed, placement of the concrete at different location, then compacting that concrete and finally curing that concrete. Now, batching can be done manually or using mechanical devices. Even mixing can be done manually for smaller quantities of concrete and mechanically for larger quantities of concrete. With respect to mixing, we can also use machines which do continuous mixing for larger quantity of works. Transportation, of course, will depend upon what quantity of concrete we are dealing with and the distance between the place of mixing and place of placement. Placement of the concrete will be done using certain devices or tools to ensure that the correct shape and the correct consistency is maintained. The proper surface or uniform surface is generated. To make sure that the surface is uniform, we can also compact the concrete using vibrators of different type. This will ensure that the air gaps which are there in the concrete is removed. And finally, we will have to cure the concrete over a certain period of time, 7 to 28 days, depending upon the scope of work. The next module is on damp proofing. So, there is a problem of dampness, that is hygroscopic moisture or gravitational moisture can impact our structure in internal spaces. This can lead to several problems and defects in our finished surface as well as internal members. Now, damp proofing is done to ensure that we form an impermeable barrier which will prevent the entry of moisture into the building and will not harm the internal structure. There are several causes of dampness. Water can rise through the walls from the ground. Rainwater travelling from the wall tops can also cause dampness. Rain beating against the external walls, deposition of condensation and poor drainage or defective construction can lead to dampness. There are 6 methods of damp proofing. We can have a membrane damp proofing where we are providing an impervious membrane. Integral damp proofing where we are actually changing the chemical composition of the cement concrete by adding certain materials to it to make it damp proofing. We can have surface treatment. We can also have creation of cavity walls where we have 2 leaves of walls with a gap in between. The outer leaf protects the internal leaf from the rainwater coming from the outside. We can have pressure grouting and uniting. So, these are the predominant methods of damp proofing. Now, common materials which are used for DPC include hot bitumen, mastic asphalt and metal sheets. Metal sheets can also be lead sheets, copper sheets or aluminium sheets. Bituminous or asphaltic felts can be used. We can also go for a combination of sheets and bituminous felts. Bricks can be used for damp proofing as well. Stones, mortar, cement concrete and plastic sheets also find application. Now when we are doing damp proofing, we do it at all levels in the building. So we start by preventing the foundation from taking up gravitational water. At the basement, we can protect it by forming either foundation drains around the basement, creating an RCC raft or wall slabs all around. We can also do mastic asphalt tanking. Asphalt tanking is done on all the sides and even at the bottom, and then covered with a layer of brick to ensure that moisture doesn't come in from the sides. At the internal level, we do it at the floor level, for walls, and also at the roof. So every place where we are changing the material, or maybe a structural member is meeting with another structural member or in infill wall, that gap is actually sealed with the help of some type of damp proofing. With respect to flat roofs, we have to do an extra care on the top. We have to do terracing, which is the top finish that is provided above the floor slab. Now, any flat roof is a roof which has a slope less than 10 degrees. No roof is entirely flat because some amount of drainage has to be provided. We have to drain out the storm water, that is rainwater, which is coming on top of the roof. To be able to do that, we need some slope. So, nothing less than, it cannot be 0 degrees. It has to be some angle. So, on top of this, a certain amount of terracing is done. This terracing can be done using many processes. We can have some amount of mud terracing. That's a very common affordable way of terracing. We can have mud fushka terracing with tile paving, lime concrete terracing with tile paving. We can have light roof materials, metal members, etc., sheet decking on top to protect it. We can have timber or concrete flat roofs, and it is treated accordingly. We can use brick, jelly or madras terrace roofing, lime concrete terracing, and of course Bengal terrace roofing on top of our flat surface. The next module talks about, now we are going into the finishing of the building. So we've done with the foundation, the walls, the doors and windows, damp proofing, the roof on top. We've done the terracing of the roof as well. Now we're going for the finishing of the walls to give our building the aesthetic look that we want. So first we start with plastering and pointing. So plastering is the process of covering the rough surfaces of walls, columns, ceilings and other building components with thin coats of plastic mortar to form a smooth, durable surface. Now the coating of plastic material, the mortar which is termed as plaster, if this is being done on external exposed surfaces, it is known as rendering. Now mainly there are three types of plasters that we use. We can have lime mortar plaster, cement mortar plaster and lime cement mortar plaster. The term pointing refers to the finishing of the mortar joints in masonry. If they're in exposed masonry, the joints are considered to be the weakest and the most vulnerable spots where the rainwater will target the building. So the pointing consists of raking the joints. So we are basically creating scooping out these joints to a depth of about 10 to 20 mm, and we're filling it with better quality mortar and we're giving it the desired shape. So externally the building will look better because we are finishing these joints and making them look uniform and pristine. Now pointing can be done in various ways. The different names actually denote different shapes that we scoop out the mortar and put the new mortar in as. That shape could be in flush pointing, it is absolutely plain. We can have tuck pointing, V pointing, it's V shaped. We have weathered pointing, beaded pointing is a little projection is created on top above the mortar joint. We can have struck pointing, recessed pointing and rubbed, keyed or grooved pointing. Now this is different types of pointing, again reminding you on the basis of the shape, the final shape that we're going to give to the mortar joint. Now plastered finishes can also be of different textures. We can have a smooth cast finish, a sand faced finish, rough cast or spatter dash finish. We can have a pebble dash or dry dash finish, depeter finish, scraped finish and textured finish. So the final look of the plaster can also have different textures. After we are done with our plastering and pointing, we would have to go for painting of our buildings. Now paints are liquid compositions of pigments and binders which when applied to the surface in thin dry coats form a solid film to impart a decorative finish, apart from giving protection to the base material from weathering. Now common types of protective and decorative coatings include oil paint. Here the drying oil, vehicles or binders plus opaque and extender pigments are mixed. For water paints, the pigments plus vehicles based on water, casein, protein, oil emulsions and rubber or resin latexes separately or in a combined form are used. Calcimine is water and glue with or without casein plus powdered calcium carbonate and any desired coloring pigment is used. We have varnish. This is a transparent combination of drying oil and natural or synthetic resin. The common types also include enamel. It is a mixture of varnish, vehicle plus pigment. Lacquer, which is a synthetic resin film former, usually nitrocellulose plus plasticizers, volatile solvents and other resins. Shellac is a type of resin secreted by the lac insect which is dissolved in alcohol. We have aluminium paint where fine metallic aluminium flakes are suspended in drying oil plus resin or in nitrocellulose. Any paint is made up of 5 components. The first is called a base, then followed by a vehicle or carrier, a dryer, a coloring pigment and solvent or thinners. So these 5 together will form paint. There are common types of paints available in the market, each having its own characteristic properties and they can be applied to different parts of the building or for different purposes. It includes aluminium paints, anti-corrosive paints, asbestos paints, bituminous paints, bronze paints, casein paints, cellulose paints, cement-based paints, colloidal paints, emulsion paints, enamel paints, graphite paints, oil paints, plastic paints, inodorous paints, silicone paints and synthetic rubber paints. Distemper is water-bound. Distempers are usually coming in powdered or paste form and are mixed with hot water before use. Oil-bound distempers are a type of oil paint in which the drying oil is treated to allow mixing with water. Now, glue or casein acts as an emulsifying agent. These are washable. Distempers are cheaper than oil paints and they are generally light in color and provide good reflective coating. They are less durable than oil paints though. Whitewashing of surfaces can also be done. Whitewashing is basically providing successive layers of the whitewash on the rough surface. Now, in order to obtain a cheap, clean, neat uniform finish, it is necessary to adopt for a proper method of both preparation of the surface as well as finally finishing to give an easy application of the whitewash. Now, whitewash and distemper has some basic differences. Last module deals with temporary structures which are needed for us to be easily able to do the construction process. The first type of temporary structure is called shoring. Now, these are temporary structures that are constructed to provide some temporary support to unsafe structural elements of the building. So, let's say a part of our building is damaged and it is going to collapse. So, to be able to give it some support, we do shoring. So, it provides lateral support to these walls. Now, shoring can be done in different ways. The first is called raking shores. Now, these are inclined members which are supporting adjacent wall. It has multiple types of constituent members. The second is called flying shores. Now, this is an alternative and this is used when we want a clear working space at the ground level because flying shores, as the name suggests, isn't connected to the ground. Raking shores actually have to take support from the ground at one point, but flying shores are supported at an upper level, either from an opening or from a chhajja or at the lintel level of an upper floor. So, essentially flying shores are not touching the ground. So, you have clear working space at the ground level. Even if you are dealing with a part of a building at a much higher floor, which is quite far off from the ground level, we can go for this type of shore. Now, dead shores are mainly done to provide vertical support if you are creating an opening in an existing wall. So, if you want to support the upper portion of the wall, so we can have 2 vertical members inside and outside that room to provide support while we create an opening within this wall. Scaffolding is the second type of temporary structures and these are created to provide workers with a platform. See, essentially anything above 1.5 meters of height, if we are trying to do construction, we cannot really access it easily. So, for a person to, let's say, paint the ceiling or do masonry work above 1.5 meter, how would we reach that point? So, to be able to do that, we need an elevated platform above which we can stand and do the work, and that is what refers to as scaffolding. Now scaffolding can be single scaffolding. Here there is only one single layer of vertical member supporting the boards or the platforms above which people stand and work. In case of double scaffolding, which is also independent scaffolding, here you have two vertical sets of members. So what happens is that now we do not have to take support from the adjoining wall. Say we are dealing with brick masonry, it is possible for us to attach our scaffolding to the wall. But if we are dealing with stone masonry, which is very difficult for us to make holes in, how would we support our scaffolding on the wall to ensure that it doesn't topple over while the construction is going on? So we need to be able to have two vertical sets of members supporting independently above the ground. So that is double scaffolding. We also have cantilever or needle scaffolding. Suspended scaffolding, here you are suspending it from the roof level with the help of pulleys. Trestle scaffolding is kind of like a platform which can be moved from place to place based on where you are working in the construction. Steel scaffolding, here it's similar to the previous types, but essentially all the parts of it is made up of steel. And patented scaffolding has specific joints and members. Underpinning is a process by which we replace an existing foundation with a new one. So we do not want to damage the building above it. We just want to isolate that superstructure and create support for it so that we can work underneath and replace certain sections of the foundation one at a time. Now generally we replace alternate sections of the foundation. So this can be done again by various methods. Most traditional one is the pit method. We can also have the pile method. Underpinning to specific walls, jack pile underpinning, needle and pile underpinning, Pineford stool method of underpinning, root pile or angle piling underpinning columns, and there are other miscellaneous approaches as well. With respect to the pit method, we are essentially working on alternate sections. A needle is used which is supported on both ends, either on a structural member or on fulcrums, and this is kind of supporting the upper structure. It allows us some amount of support so that we can work on the foundation underneath. But we don't do it in one go, we do it in sections of say 1 to 1.2 meters, and we do it in alternate sections. Now formwork or shuttering is a temporary ancillary construction which is used as a mold for a structure. So if concrete has to be poured into a mold, this mold that is being done is the formwork. The cost of formwork accounts for about 20 to 25% of the cost of the structure. We can make formwork using wood, plywood, steel, a combination of wood and steel. We can use reinforced concrete and plain concrete also for these purposes. Timber and steel formworks are most commonly used. Centering is the part of the formwork which supports the horizontal surface. So if you are doing a slab bottom or a beam bottom, arches, then we are doing centering. Now if we are going for vertical, that will be the other parts of the formwork. Now we have taken a quick look at each of the different subcategories that we have studied of the building components in the various modules. Just taking a quick recap of what we've learned so far in this particular course. We first started with foundation. Here we took a look at shallow foundation and deep foundation. Then we went on to masonry. So we saw brick, stone and other types of masonry. Then we went on to flooring. So we saw the ground flooring and then upper floors, and we also saw different types of floor finishes. Then we went on to doors and windows and its various subtypes. We took a look at roofs and what are its subtypes. We went further in detail of pitch roofs. We saw PCC and RCC construction as well. We saw the different methods and materials that can be used for damp proofing. Then we saw the finishing aspects, that is starting with plastering and pointing, and we went on to painting of our structures. And finally we saw temporary structures like shoring, scaffolding, underpinning, formwork, which includes centering, to be able to do that construction with ease. So these are some of the references we have used in this particular course. You can further study them in detail. So thank you for taking this journey with me, learning the basics of building construction. We've learned a lot throughout this course. I hope to bring you new courses in the future. Till then, thank you and goodbye.